In this question, there's a couple of parts, but the first part is finding the stationary points of this curve up here. This curve y equals 2x cubed plus 3x squared minus 12x plus 7. So we need to find the stationary points and determine their nature. So the first step of that is differentiating and then finding the second derivative as well. All right, so let's do that to get started. So y is equal to 2x cubed plus 3x squared minus 12x plus 7. All right, let's get started. So I'm going to find dy dx. Should we take one off the power and multiply the whole term by the old power? So 2 times 3 is 6, x squared, do the same thing again, 2 times 3 is 6, x to the 1, so it's just 6x. Take one off the power, it's just constant, so we just get 12, and then this disappears. Now let's find the second derivative as well, so d squared y dx squared. Do the same thing again, 6 times 2, 12x, and then that just becomes a 6. So there are our first derivative and second derivative. So now what we need to do is for stationary points. So for stationary points, dy dx is equal to 0. So we get 0 is equal to this over here. So 0 is equal to 6x squared plus 6x minus 12. So we can see there's a common factor here, 6, so we can take that out. We're left with x squared plus x minus 2. Now we can just cancel that 6, it disappears, so we just get 0 is equal to x squared plus x minus 2. Now, a couple of different ways to solve this quadratic. I'm just going to use the cross method because it's quite a simple, easy quadratic to solve. Only 2 options there. Here we can either have a 2 and a 1, so we know they're going to be 2 of the options, and one of them is going to have to be negative. So if we go x times 2 plus x times 1, we get 3x, so we need to sort it so we get net plus x here. So I think if we put a negative on the 1, we'll get negative x plus 2x, which is just x. So that's how we know that's right. So we get 0 is equal to x plus 2, x minus 1. And there you have it. So therefore, x is equal to negative 2 or 1. So we know there's going to be stationary points at those 2x values. But what we're also going to need to know is their concavity at those 2 points and what's happening there. So the way we do that is we substitute those 2 values into both our second derivative to get the concavity, but then we also need to sub it into the original equation just to get where that point is. Okay, so let's firstly do the first one. So let's say at x equals negative 2, y must be equal to 2 outside of negative 2 cubed plus 3 negative 2 squared plus, minus 12 times negative 2 plus 7. And chuck that in the calculator, we get 27. So therefore we know that the point is negative 2, 27. Now the question is that concave up or concave down? So the way we do that is we use the second derivative. So second derivative, d squared y dx squared is equal to 6 outside of 2 bracket negative 2, because we've got to put in the x equals negative 2, plus 1, all brackets. And that just comes to negative 18, which is less than 0. So therefore, it's concave down. And we can say that negative 2, 27 is a local maximum. And that makes sense, right? Because if it's concave down like so, it's a maximum point that we have at this stationary point here, okay? All right, let's do the other one. So again, at x equals 1 this time, y has to equal 2 outside of 1 cubed plus 3, 1 squared plus, minus 12 outside of 1 plus 7, which comes to 0, actually. So it's at the origin. So our point's going to be 1, 0. And then we need to do the concavity. Same as above, 6, 2, and that just comes to 18, which is greater than 0. Therefore, concave up, and again, I'll just do a little drawing. It's going to be a local minimum. So remember, we got to write our final solution again. So we'll get 1, 0 is a local minimum. Okay. And it is always good practice just to underline your answers just so they know when they're marking what they're looking for. So there's our two answers for the first part of the question, for part I. All right, let's go back to the question here. So for the second part, we're going to have to sketch the curve, and we need to label all the stationary points. So let's go back down. We've got our 2 points. Now, if we know there's only 2 points, it's probably going to be a cubic. And we're going to have to label those points. So let's see how good I can do that with this tool. All right, let's draw ourselves some axes like that. And then I'm going to draw on the 2 important points. There's a point at x1, 0, which is there. So I'm going to label it 1, 0. And we know that's going to be a minimum, right? So it's going to come down and up like that, right? And then the other point is a maximum at -2, so let's say about there, and all the way up at 27. So let's draw it in there. -2, 27. Okay, let's see how I go here. So we're going to be coming down to the local minimum, and then back up, local maximum, and then down like that. Okay. And remember, you're not going to get all the marks unless you put all the relevant things on. You've got to put the axes like this, arrows. You've got to label them. This is X, this is Y. And it's good practice to label the curve itself. So if we've got room, we can just write it here. So it's 2x cubed plus 3x squared minus 12x plus 7. Okay. All right. So for the final question, or final part of this question, if we quickly go back up to it, is hence or otherwise find the values for x for which the first derivative is positive. So this is pretty easy. We can just read this off the graph that we just drew. So for what values do we have positive derivative, right? So positive derivative is when we have a positive gradient. So it's all positive here, it's negative here, and it's positive here. So we can say that dy dx is greater than 0, so it's positive when x is less than -2, bracket x is greater than 1. So this section here and that section down there.
Snack is an online platform to instantly create and share videos just like this one. To watch more or try a hand at making your own, head over to snackapp.io.